Okay, today we're going to solve a problem with two variables. We're going to have word problems, okay? So these word problems are word problems that you've seen before. Like in first semester, how many variables did we use in first semester? One. We're going to do the same exact word problem using how many variables now? Two. That's the only difference. Does that make sense? Okay, so if you really wanted to, you could just use one variable and solve. But we're going to show you how to use two variables. It turns out it's a little bit easier doing it that way. Okay, so here we go. So before we begin, because we're going to be using two variables, here's a fact, write this down. When we use two variables, we need blank different equations to solve. How many different equations do you think we're going to need? Let me give you a hint. When we had one variable, how many equations do we have? One. If we have two variables, guess what? How many equations? Yeah, we're going to need two equations, okay? What if I have three variables? How many equations would you need? Three. If I have four variables, then you would need four. If I had 10, you need 10, and so on. Does that make sense? So that's how you solve linear equations having, right? If you have two variables, then you need two equations, two different equations. Okay. So since we'll be using two variables today, guess how many equations we're going to have? Two. Does that make sense? And it's going to make things a little bit simpler than before, okay? Because before we just use one variable and so on. And if you really think about it, we really use substitution method, if you think about it. But anyway, here, let's move on to these equations. Okay, so here's number one. Somebody read this for us. How about, yeah, go ahead, Chuck.
The sum of two numbers is 5. The larger number exceeds twice the smaller number by 14. Find the numbers.
And as you can see, this is the exact kind of question that you had before, right? In first semester and so on. We're just going to use two variables now. Because how many unknowns do we have here? There are two unknowns, so we're going to use variable for each of those unknowns. Okay? So what are the two unknowns? Somebody tell me what the unknowns are. How about Paige? Yeah, let x to be what?
5 minus 5.
Oh yeah, so that's using one variable and so on. So let x to be the, what are the two unknowns we have here, Klaus, again? The unknowns are what? Look at the question. What are the two unknowns? There are two unknowns, right? What's one of them? Smaller number. The other is? Larger number. That's it. So let x to be what? The smaller number. Okay? And we don't do then now because we're going to declare another variable. Then, instead of then, we're going to let again. Which variable should we use for the other one? Larger one.
Y.
Let y. Yeah, let y be the larger. Okay? So we're going to use two variables to solve this word problem. Okay? And so we got two variables. We need how many equations?
2.
We need two equations. Okay. So can somebody give me one of the equations looking at the problem? And yes, Christina?
X plus y equals 5.
Very good. X plus 5 equals to 5. That equation is the one that where people always mess up the most or they forget because it is so obvious. It's right in the front, right in the very first sentence. People like kind of skip that one. But Christian is right. Look, it says the sum of the two numbers is 5. So of course, if you add x plus 5, don't you get? X plus y, don't you get 5? Is that easy? So please don't forget about that one. Because if you forget that sentence, you're not going to be able to solve this because you will only get one equation. What's the other equation? It says the larger number exceeds. What does exceed mean? It's how much greater, right? It's greater. How much is it greater? Livy, what do you think?
Y equals 2x plus 14.
Exactly. Y is equal to 2x plus 14, and that's what it means, right? The larger number exceeds. How larger number is bigger than? How is it bigger? How much bigger? It's twice of the smaller by 14. So you square. Not square. You multiply x by 2 and add 14. Do you see how we get two equations now? Do we know how to solve this system? Which method should we use? We know three methods: graphing, substitution, or adding method. In this case, isn't it nicely set up for substitution? Do you have to use substitution? No. I could move the 2x on the other side and add it and so on, right? By multiplying the bottom one by -1, right? But this is nicely set up for substitution, so why not use substitution, right? Go ahead, everybody try. I'll wait. By the way, would you like to use graphing on this one? Probably not. You could, but probably no one will do that. Everybody go ahead and try. I'll wait. All right, so how many people got this third equation this way? X plus 2x plus 14 equals 5. Very good. In place of y, substitute that in. That's why it's called substitution method. Look at my third equation. How many variables do you have on the third equation? 1. Isn't that what we want, right? Once you substitute in, you should only get one equation because we know how to solve, right, an equation with one variable, right? Matthew, what did you get? X equals negative 3. How many people agree with Matthew? Okay. How many people have different answer? Okay. Matthew is correct. So because, this is, you could get rid of the parentheses, right? Because it's really 1 times this parentheses, right? So you get 3x plus 14 equals to 5. Subtract 14 from both sides. You get x equals to negative 3. Correct? Yeah. And of course, we're not done, are we? Aiden, what do I need to do?
Plug in x to
Yeah.
the equation.
I need to plug in x to one of the equation, right? So I can find the other number. Which equation would you like to use? The first one or the second one?
The first one.
The first one is easier, right? Doesn't matter which one you use, right? So what's the here you could use first or second. You get y equals to 8, right? Regardless, because it's a solution to the system. So since it's a word problem, do you think we need to do all those 5 steps? Yeah. What was the last step? We have to write in as a sentence. So Christina, what would you write?
The larger number
Mm-hmm.
is the larger number is 8,
Mm-hmm.
and the smaller number is negative.
You got it. The larger number is 8. The smaller number is negative 3. I just wrote down the numbers are negative 3 and 8, but I like how you wrote that. It's better, right? Because they said, it says find the number, so you could just write it this way. Unless they say what's the larger number, what's the smaller number. But that's fine. So you got to write it as a sentence. Now, of course, when you have time, you should check. Does this look like it's correct? So let's add them together. It should equal to 5. Does it equal to 5? Yeah. Okay. So is that the only one you should check, or should you check the other one also? You got to check both, right? Because it's got to be solution to both equations. So the other one is 3x plus 14. So what was x? X was negative 3, right? So if I were to multiply negative 3 times, the second equation was, y is equal to 2x plus 14, right? So x was negative 3, so let's plug it in. Do we get 8 as the answer? What's negative 3 times 2? Negative 6. What's negative 6 times, plus 14? 8. So y equals 8, it checks out, right? So that's the answer, right? So you got to check both equations, okay? It's not good enough to be true for one of them, right? It's got to be true for both. All right, do you guys see how this works? Okay, using 2 variables, it's a little bit simpler if you actually think about it, okay? But it's the same sort of process. May I move on to example 2 then? Yes? All right, here we go. Okay, Kevin, can you read this for us?
Tickets for the senior play
Uh-huh.
cost $4 for adults and $2 for students. This year there were 600 tickets sold and the class paid $1,900. How many of each type of ticket were sold?
Very good. Now, do you guys remember questions like this before? Have we done something like this? Yeah. So, only difference is we could actually do this using only one variable, but I'm going to show you how to do it using 2 variables, right? So that it's a little bit simpler. Claire, what are the unknowns in this question? Because that's what we have to first ask ourselves. How many unknowns do we have here?
2.
2, and what are they?
How many of each type of tickets? So the adult tickets and the student.
Right. How many? Very good. I like how you said at the end, how many. We want to know how many adult tickets were sold and how many student tickets were sold. Isn't that what we're looking for? So there are 2 unknowns. Guess what? How many variables are we going to use? 2. That's it. So let x to be, let's just use x. Let x to be what? The first one, number of adult tickets? Sure. Number of adult tickets. That's what I said. What about then, since we use x, let's do let y be what? Number of
Student tickets.
student tickets. Does that make sense? Easy enough? Yes?
Yes.
And we give you a chart. So let's use the chart because chart's going to help us to come up with the equations. So you've seen this chart before, right? Price times number of ticket gives you the cost for each of these. So for the adults, what's the price for the adults? What should we plug in for price for the adult? Song, what did they say? They say for adult ticket it is $4, and then for students, 2. Very good. Does that make sense, guys? So there you go. By the way, can I put anything down for total here underneath? Does anything go underneath? Does anything go into this box underneath the price for total? No. Okay, that's separate, right? Adult is for students too, you don't know the total price, right? For each of these tickets, it's different. What about number of tickets? How many adult tickets have we sold? 6? X. We don't know. How many student tickets have we sold? Y. That's what we, right? And now for the number of tickets though, for total, we could write that down. Can we not? Because X plus Y doors over, right? Number of tickets that were sold, we know how many total number of tickets that were sold. So you could, yes, go ahead. Very good. Don't we know that it's 600? For now, in terms of chart, we're going to write it this way. Knowing that it's 600, guess what's that going to give us? That's going to give us the, yeah, that's going to give us the equation. Does that make sense? So for the chart, I'm going to just write down X plus Y, and of course, we know that it's 600, so that's going to give us one of the equation. Very good. What about for the cost? Well, if each of the tickets for the adult costs $4, and there were X number of adults, what's the cost? How much do we earn from selling adult tickets? 4X, right? What about for students?
2y.
2y. So what is then the total cost that we got from selling all these tickets?
900.
Yeah, well, we know it's 1900, but right now, in terms of chart, let's just write down what we know. 4x plus 2y is equal to, 4x plus 2y, right? And because we know that it equals to 1900, guess what? That's going to give us our second equation. Because we're using two variables, we're going to need two equations. Does that make sense? So go ahead and write down those two equations and solve. I'll wait for you. Okay, go ahead, everybody try. First of all, come up with those two equations. And then I will solve. I'll give you time for you to solve. So here we go. We need two equations. Somebody give me one of them. Okay, we're using two variables, so we need two equations. Yes, two people. Okay, how about Sammy? X plus y equals to 600. Is that right? Correct. Yeah, how come we don't put x plus y equals to 1900?
Because that's not true.
Yeah, that's not true. Why is that not true?
Because how many tickets?
Yeah, x and y represents number of tickets, right? So, number of tickets, right? We sold together, total of 600 tickets. That's not the actual amount of money that we get. But what is then the amount of money we got from this? Chase, what do you think? I mean, Chuck.
Oh.
Sorry.
4x plus 2y equals to 19.
That's the one that equals 1900. Does that make sense, class? Yes? Okay, so do you see how we get two equations this way? Please don't get these two things mixed up, right? 600 represents number of tickets, so x plus y to give you 600. 1900 represents 1900 represents how much total amount of money that we received, right? And so we have to use the one with the cost, right? 4x represents the amount of adult tickets that we earn, the amount of money we earn, and then 2y represents how much, right? Just from selling student tickets, how much we earn. Does that make sense? Okay, everybody then go ahead and solve. By the way, what method do you think is appropriate to solve this system? Hint, hint. Look at both of these equations. They're in standard form. Aren't they both in standard form? So which method is useful to solve? Adding and subtracting method, right? So you can multiply the top one by either -2 or, if you were to multiply -2, you get rid of the y. Or -4 to get rid of the x. Doesn't matter, right? Which one's easier? Multiplying by -2, right? Small number. Oh, some of you say, wait a minute, could we, yes, very good. So could we simplify the second equation as 2x plus y equals 950 before we do anything? Yeah, that may be easier. So always simplify if you can. Carly notices, well, look at this equation. I could divide left side and right side by 2. Makes it much easier. Yeah, so it doesn't matter whichever you wait. But yeah, it's much easier when you simplify, isn't that right? Go ahead, everybody try, I'll wait. Okay, so it turns out you could just multiply the other one by -2. It just works out nicely too. Okay, go ahead, everybody try, I'll wait. So some of you did substitution method, is that okay? Yeah, that's fine. I mean, doesn't matter. I mean, here I forgot to even simplify this. I just multiplied the top one by -2. Is that okay? Can I still do that?
Sure.
Yeah, it still works out. So when I do this, I got x equals to 350. But if you simplify this, it's a little bit easier, right? If you simplify the second equation to this. But anyway, how many people got x equals to 350? Good. What does that represent? Yeah, number of adult tickets. Does it represent how much money we earn? No, that's 350. It's not $350, is it? It's 350 number of tickets we sold. Okay, some of you didn't get this. Go ahead and help each other out. I'll wait. Okay, if you didn't get that, help each other out. You should have gotten x equals to 350. Go ahead. Help your team. Okay. Okay, so then we're not done. We need to find out what y is. Y represents number of what? Student tickets. So how do I find y? Okay, Brandon, what should I do? Yeah, you plug into one of the equations. We have two of them. Which one is the easiest? X plus y equals 600. Is that the easiest one? So of course y comes out to 250, does it not? So there you go. So you need to write this as a sentence. We sold 350 adult tickets and 250 student tickets. Is that okay? Of course, if you have time, you should check and see if this is right. Of course, when I add them together, it goes to 600, so that's pretty good. But you gotta plug into the second equation, right? Was 4x plus 2y equals 1900, and it does come out that way. Any question? Does this make sense? So do you see what do you guys notice? By using two variables, even though you have to deal with two equations, do you see how it makes it a little bit simpler by solving it? Because we know we know the methods of solving these, right? Like addition methods, it makes it so much easier. All right, let's move on to example 3 here. Okay, somebody read this for us. How about Michael?
Kathleen invested $5,000, some at 6% and the rest at 5%. Her annual income from the investment is $280. How much is invested in 5%?
Correct. So here, how many unknowns do we have? Chris, how many unknowns do you see? 2 of them. What are they? Yeah, amount. So this is how amount. In other words, how much money this person invested for 6%, right? Investment and 5% investment. Does that make sense? So there are 2 unknowns. So we're going to declare our variables. Let x to be what? How much she invested in? 6%, and let y to be how much she invested in? 5%. Actually, I did x for 5%, y for 6. Is that okay? Right. Yeah. So. Okay, so that's good. Now, look at the chart. This chart, we're used to this kind of chart, aren't we? By the way, what's principal? What do they mean by principal? Yes.
How much they invested.
Yeah. So another word for how much they invested is called principal, and interest is how much they, right, of course, made from that interest, right, investment. Does that make sense? So go ahead and fill out this chart. Okay. First of all, this on top is going to be 5%, right, investment. The other one is what? 6% investment, right? Go ahead and fill out this chart. I'll wait. Everybody try. Okay. So take a look at this. As we said before, the principal, it just means how much money the person invested, right? So Camilo, how much is this person invested for 5%? X. We don't know that, right? Amount. So that's why we call that X. What about for 6%? How about let's see, Libby? No, I'm talking about the money invested. Why, exactly. But yes, you're right. The rate, what is the rate for 5% investment? Hint, hint, it's 5% investment. So what's the rate, guys?
10%.
Do I write 5 or do I write, yeah, very good. You don't want to write 5, do you? Because then it will mess it up. Okay, you want to write point, what? Is it 0.5 or 0.05? Yeah, be careful. If you write 0.5, that's 50%. Right? Investment. That's awesome. That doesn't happen that often. Okay, and then what about for then the rate for the 6% is 0.06. And so how much money then did the person make just from the 5% investment? Yeah, 0.05 times x, and of course the other is 0.06 times y. Does that make sense? And let's look at what we could put down underneath. So the money invested. Could we write down something about the total of money invested? Is it possible? Yes. Because we invested X dollars, right, on 5% Y dollars. So it's what, class? X plus Y. Can we put down for anything for the rate here? No, that we leave blank because rate, is separate for both of these. So you can't really talk about that in total. And then for the interest, meaning the amount of money the person earned, could we write that as a total? Yeah. Well, we know it's 280, but right now, as in terms of the chart, we're just going to add these together. Does that make sense? So we're going to add 0.05x plus 0.06y, and you're right, Chuck. That equals to what? 280. That's going to give us one of the equation, and of course, x plus y equals to what? 5,000. That's going to give us another equation. Does that make sense? So go ahead and come up with those 2 equations, and I'll wait, and then you guys solve it afterwards. Here we go. Go ahead and finish it up. Boys, give me one of the equation then. look at the chart, because chart's going to help us come up with those two equations. Yes? Yeah? Okay, good. So for the interest, we know that it equals to 280. Very good. When I add them together, so that's one of them. What's the other equation that we need? Because that's only one equation, Royce. We need the other one. Look at the chart. Look on the bottom. We use this one. So do you know anything about x plus y? X is how much money the person invested for 5%. Right? And then y is how much money the person invested for 6%. So what can you tell me about x plus y, Royce? Look at the question. Okay, read the very first sentence. Okay, so what should x plus y equal to? 6,000, yeah. I mean, no, not 6,000. 5,000, right? Does that make sense? Please don't forget that. That's the simplest, right? That's the easiest one you can come up with. Like I said, people always forget that. They always forget that first sentence, right? X plus y should equal to 5,000, right? Whereas if you add up the interest, it equals to 280. Yes? Now, do we know how to solve the system? Well, look at the second equation. It's not so nice, is it? Is there a way to get rid of all these decimals? Michael? Multiply both sides by 100, and it just simply becomes 5x plus 6y equals to 280,000. No, 28,000. Does that make sense? Right? Isn't that nice? And then you're gonna use the addition method, right? So go ahead and everybody try. I'll wait, okay? And go ahead and use the addition method to come up with this answer. So how many people? Okay, put them vertically and then multiply the top by -5 and so on. Okay, did anybody multiply top by -6? Could you have done it that way? Yeah, it doesn't matter, but I just got rid of the x first. It doesn't matter. Okay, so when you do, okay, don't you get this? How many people got y equals to 3,000? Okay, good. If you didn't, go ahead and ask your group. Okay, I'll wait. Go ahead. You should have gotten y equals 3,000. By the way, did they ask for the y or did they ask for the x? Look at the question. Do they ask for the x or do they ask for the x? So once I found y, it's okay to find. You can find y, but we could figure out what x is, right? Because x plus y equals to 5,000, the x should have been what? 2,000. So if you actually multiply top one by -6, you would have gotten x straight, but it doesn't matter, right? If you know y, you know x, right? It's easy. So you should have written down as 2,000 was invested at 5%. Does that make sense? Okay, if you didn't get that, go ahead and help each other out. I'll wait, okay? So you should have gotten x equals 2,000, y equals to 3,000. Go ahead, everybody try. I'll wait. Help each other out, okay? Okay, so how many people got now? How many people know now y x equals to 2,000 and y equals 3,000? Does this make sense? Can you do something like this for your homework tonight?
Yes.
Very good. Okay, good.